Hello, everyone. My name is Dr. Wright, and today I'm going to be talking about fractions. More specifically, I'm going to be talking about comparing and ordering fractions. I'm going to run straight into it so I can get in and get out. So if you're here, I'm assuming that you need some help on fractions, which is cool. I love fractions. Fractions, something you should know about fraction. These are fractions that equal 1. So whenever the numerator and the denominator are the same, whenever the numerator and denominators are the same, it equals to 1. This is important to know because it is going to matter when we begin to compare and order fractions. All of these fractions equal 1. Every one of them equal 1. Okay, same thing for all of them. And you can read them as 8 divided by 8, or you should just know that anytime there's the same numerator and the same denominator, it equals to 1s. So these are considered equaling to 1. Now you have fractions that equal halves, and they kind of look like exactly what they say. They equal halves. We have 5 over 10, because the numerator is half of the denominator. We have 3 over 6. Again, that's a half because the numerator is half the denominator. And then we have 2 over 4. These are considered halves. That's what they call them, halves. Because I know sometimes you could be a parent looking at this and you're like, what in the world is going on? Yes, these are example of fractions that are equal to 1, and these are halves. So let's kind of move on. Let me erase this, clear this out, and let's get straight to it. All right, remember at any point you can feel free to slow it down, to rewind, and to go back to what I have written. So if we're comparing fractions and they have the same denominator or numerator, we are happy. We're very happy. Okay, so with this one, for instance, we have 1 over 8 and 5 over 8. And let me just write another one. Then we have 2 over 3 and 1 over 3. With both of these, the denominators are the same. Whenever the denominators are the same, we say thank you, because these are the easiest ones to do. And whenever the numerators are the same, it's a little bit more interesting, but nevertheless, still not as much work. All right, so I'm going to put up these 4 fractions and let you know how it kind of works. Now, first we have 1 over 8 and 5 over 8. Okay, and because the denominators are the same, this is straightforward. I know that 1 is less than 5. So therefore, 1/8 is less than 5/8. That's pretty straight to the point. Again, the denominators are the same. So therefore, I look at the numerators. Whichever one has the biggest numerator is the biggest number. Now, it's different when the numerators are the same. You look at the denominators, and whoever has the smaller denominator is actually bigger. Think about it like this. If you're eating a pizza, right, and you have 7/8, that means you've got to eat 7 out of 8 slices. But if you have 7 over 10, you still have 3 slices left. And if you are greedy and you're really hungry, you want to have all your slices. So when the numbers are closer, or when that denominator is smaller, that is a good thing. That means the number is actually bigger. Same thing here. This 9 is bigger than this 2. That makes 1/9 less than 1/2. Again, if we were to do this on a picture and I had a pizza, okay, and I cut it into, because I remember first seeing this and being like, what? That makes no sense. That makes absolutely no sense. Oh, but it does. Okay, so this pizza is currently in ninths, right? So if I shade in only 1/9 here, and then I come over here and I make another pizza, and it's 1 out of 2. The bottom number tells me how many sections there are. There are 2 sections, okay? And the numerator tells me how many to select. so I only select 1. Look at this pizza. This person ate more than that person. This person has more. They have a whole half. This person only got 1/9. So that's how you know which one is greater and which one is smaller. Okay, here now I have 2 fractions. Here's the problem. Neither the numerator or the denominator is the same, and this is when most folks start to panic. Now I'm going to show you how I can use halves. Remember we went over what halves were. How I can use halves to make them show the same denominator and help me to compare them. Okay, so using halves, I would start with this number, 2/10. Note something, the denominator will stay the same. I'm going to use halves in order to rename the fractions and compare them. So, oh, look at that. I'm writing the wrong one right there. This one should have an 8, okay? So all I did was rewrite this one, but I left off the numerator because that's what I'm going to change, and rewrote this with the 8 in the bottom as well. Using halves, I rewrite the denominator and simply take half of whatever the denominator is. Half of it is 5. Same thing here. I bring the 8 down and take half of the denominator. Okay, it has nothing to do with the numerators. I take half of this denominator, which is 4. Now I compare these two. Okay, so 2/10, now they have the same denominator. This is going to make it easy for me. 2/10 is less than 5/10, right? And now let's look over here. You might be saying, how does all of this come together? It just does. That's how math works. Let's compare 6/8 and 4/8. 6/8 is greater than 4/8. So therefore, when I come back up here to put an answer, and remember I wrote this one first, so I'm just gonna simply write the sign that is associated with it. 2/10 is less than 6/8. Remember, I took this less than sign from right here. Because this fraction is written first, I took the sign that I figured out when working with those two. Simple enough? All right, let's look how it looks when we deal with ones, how I can compare using ones. So if I have, make a line, if I have 7/7, right? And then I'm trying to compare them, but and I'm going to compare it to 6/9. I can't really just compare it because one, they don't have the same numerator and they don't have the same denominator. So therefore, I'm going to use 1, making them equal to 1 to figure this out. So this is kind of cool, right? So I know that 7/7 is the same as 1. It's the same thing. So the sign that's going to go over here when I compare this one with this one is an equal sign because they are equal. 7/7 is equal to 1. So let's come over here and do the 6/9. So all I do is I always take the denominator. I work with the denominators. See, I copied down the denominator and I'm just going to put that same number in the numerator. Why did I do that? I did that because I need it to equal to 1. So it has to be 9/9. So 9/9 is equal to 1. So I can say 9/9 or 1, right? So let's compare them. 6/9 and 9/9. 6, remember they have the same denominators, so I can compare their numerators. 6 is less than 9. So therefore, when I compare this, I know that 6/9 is less than 1, and 7/7 is equal to 1. So what that means is that 7/7 is greater than 6/9. Let me repeat that one more time in case I lost you. 7/7 is equal to 1. So we're using the number 1 to figure this thing out. So because 7/7 is equal to 1, I know, okay, this fraction right here, it equals 1. So I can put a 1 up here, right? It equals to 1. But then when I do 6/9, I rewrite it by putting a 9 in the denominator, and the only way for me to make it equal to 1 is to also put a 9 in the numerator. So therefore, I've made it 1. Now I compare them. The reason I can compare them is because they have the same denominator. So now I look at the numerator. Oh, 6 is less than 9. So I put a less than sign. So that also means that 6/9 is less than the number 1. So that tells me, well, if 7/7 equals to 1 and 6/9 is less than 1, then this fraction has to be greater than that fraction. Understand? Hopefully you got that one. All right, so I'm past that now and I'm on to ordering fractions, right? So that means I want to put these fractions in order. In order for me to put them in order, I have to be able to compare them. In order for me to compare them, I need them to either have the same numerator or the same denominator, or I have to use ones or halves in order to get them to look alike. So with that said, let's get straight into it. First thing I ask myself, do any of them have the same numerator or denominator? Nope, they do not. The answer to that is no. So therefore, that means I'm going to use either halves or ones in order to compare them. I know, because I've already done this problem, that I'm going to use halves. You might not have known that, but if you tried ones, you would see why ones does not work as well. And the reason I know I can use halves is because look at this, even number, even number. Now that is an odd number, but I still know what half of 9 is, so I will be absolutely fine. So I took a glimpse at the denominators and I know, hey, I can write these in halves, and that is exactly what I'm going to do. So let me make my little arrows, okay? And change this color up. All right, so in order to write this one as halves, remember I take down the denominator, right? And all I have to do is write it half of the denominator, which is 4. So this one was already written as a half. Remember, the next thing I do, well, let's write them in halves first before we compare them, right? So the second one, I take down the denominator, which is 10. What is half of 10? 5. And then we go to the next one. I bring down the denominator, which is 9, and half of 9 is 4.5. I know that kind of looks weird, but trust me, it's well worth it to just put the 4.5 and don't ask any questions. It'll save us so much time. Okay, so now I'm comparing the top and the bottom. 4/8 and 4/8 are actually equal to each other, right? So we're using halves to compare. That's equal. Now let's look at 3/10 and 5/10. The denominators are the same, so I can look at the numerators. 3 is less than 5, so therefore a less than sign would go here. And then let's look at 8/9. They both have the same denominator, but 8 is greater than 4.5. So now all I have to do is put these in order based on their signs. We have an equal sign, a less than sign, and a greater than sign. So I know that the less than sign, these two are associated with my less than sign, so I'm going to write 3/10 first. This is the smallest fraction. Why? Because it has the smallest sign. Okay, the less than sign is the smallest sign. So who's next? Equal or greater? Equal is next. So therefore, I write 4/8. As you can see, I'm writing the original problems, the ones that are up here. I'm not writing what I renamed those as. I just use those to help me to figure things out. But these are the ones that I'm actually writing. And then after I wrote that, the last one is the greater than, which is 8/9. I have now ordered my fractions. They are now in order, and I used halves to help me do this. Hope you understood that. I hope I made it easy for you. If you have any questions, put a question in the comments and I'll try to address it. But before I leave, there is this one that I had to do. You know how people make videos, but sometimes they miss that exact one that you're trying to figure out, but no one has it? I think I have that one for you. I'm going to use ones to solve these, but something very interesting is going to happen when I use the ones. Let's find out what happens. So in order to compare and order these fractions, how I knew I was going to use ones, because I see that there's a numerator and a denominator that is equal here already. So I figured, you know what, let me just try that method. With that being said, Let's make some arrows so we can rename them and rewrite them using 1, okay? All right, so if I'm going to use ones, what number do I bring down? I bring down the denominator. It's always the denominator that moves. And I'm going to put an 8 in the numerator. Why? Because I have to make these equal to 1. Remember, 8 over 8 is the same as 1. All right, let's do the same thing here. This is already written as ones. So it is 8 over 8. So, or I can just simply put 1. Okay, it's already written as 1. Okay, and then for 6 over 7, when this gets rewritten, I bring down the 7. In order to make it equal 1, I also have to put 7 in the numerator. And then now it's time to compare. This top and the bottom, remember we're comparing top and bottom. They have the same denominator, but the 4 is smaller than the 8. Therefore, a less than sign goes with this one. These are equal. They're the same exact thing. But here's the interesting thing that happens. 6 is less than 7. All right, the numerator here, 6 is less than the 7. What happens when I have 2 that have the same exact sign? That means both of them are smaller than 1. How do I know which one I'm going to write first? Well, let me write down first what I do know. I do know that 8 over 8 is going to be the biggest one because it equals to 1. These two are less than 1. This one equals 1. So let me go ahead and get that out the way. 8 over 8 is the biggest one, and I still need to figure out what those other two are. Well, in order for me to do that, I'm going to compare 4/8 and 6/7 by simply drawing them out, okay? I know it's an unusual way, but it works. And by that, I mean, I'm going to draw two, you can make circles, you can make squares, whatever you want, but it's going to provide a visual for you to see. Your denominator, remember, I'm looking at my original numbers. Your denominator tells you how many sections there are. So there are 8 sections, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, and which one of these are the fattest? Let's go to this one, 8. All right, and this denominator tells me that there are 7 sections. 1, oh, this is juicy, 2, 3, 4, 5, 6, and 7. And then I'm just going to color it in, and I'll be able to see the difference. How does 4/8 look? Well, 4/8 looks like this. 1, 2, 3, 4, right? And then I need to do 6/7. 1, 2, 3. I'm sorry, guys. I know this is sloppy. 4, 5, 6. Now, which one of these fractions are taking up the most space? Which one of them? This one is. So this one is actually bigger. All right. It's taking up, again, this one has more selected pieces. That means I can eat more. I always look at it at food because it helps me to best understand. That means if I had some squared pizza, because seeing this is not a circle, it's telling me I got to eat 6 out of the 7 pieces, and look how much I got to. That's a good amount. Over here, I only got to eat half, which is 4 out of 8. Okay, so you can clearly see that this picture right here has more shaded in than this picture, which would make it bigger. And that's how you would solve those problems that they don't show in books that you struggle at home with. And I completely understand. All right, have a great day. You need more help? Come on back.